Welcome to our YouTube video on Azure DevOps interview questions and answers. Whether you're a seasoned pro or just starting your journey in the world of DevOps, this video is designed to help you prepare for your next Azure DevOps interview. We'll cover a range of common questions and provide in-depth answers to ensure you're well equipped to ace your interview. So sit back, relax, and let's dive into the world of Azure DevOps interview readiness. This is the part 2. Explain the concept of traffic splitting in Azure DevOps release pipelines and how it can be used for canary deployments and A/B testing. Traffic splitting in Azure DevOps release pipelines is a deployment strategy that involves routing a portion of user traffic to different versions of an application or service, typically for the purpose of canary deployments and A/B testing. This strategy allows organizations to test new features, changes, or updates on a subset of their user base while still serving the existing version to the majority of users. Here's an explanation of how traffic splitting works and how it can be used for canary deployments and A/B testing. Traffic splitting for canary deployments. Canary deployment overview. In a canary deployment, a small subset of users, the canaries, is selected to receive a new version of the application, while the majority of users continue to use the existing version. Traffic routing. With traffic splitting, a load balancer or routing mechanism directs a fraction of incoming user requests to the new version, canary, and the rest to the existing version, control. This fraction can be adjusted based on your needs. For example, 5% of traffic goes to the canary while 95% continues to the control. Monitoring and evaluation. During the canary deployment, the team monitors the canary group's behavior and gathers data on how the new version performs. Metrics like error rates, response times, and user feedback are essential for assessment. Gradual expansion or rollback. If the canary deployment is successful and the new version proves to be stable and reliable, traffic to the canary can gradually increase until it encompasses the entire user base. If issues are detected, traffic can be quickly redirected back to the control version. Traffic splitting for A/B testing. A/B testing overview. A/B testing involves comparing two or more variations, A, B, C, etc., of a feature or design to determine which performs best. In software, this could involve testing different user interfaces, algorithms, or content. Traffic allocation. Traffic splitting allows for precise control over the allocation of users to different variations. For instance, 50% of users might be directed to version A, and the other 50% to version B. This ensures a fair comparison. Data collection. During the A/B test, data is collected on user interactions and outcomes for each variation. This data is then analyzed to determine which variation performs better based on predefined success criteria. Decision-making. Based on the analysis of the collected data, organizations can make informed decisions about which variation is the most effective, and subsequently, they can choose to roll out the winning variation to all users. Benefits of traffic splitting. Risk mitigation. Traffic splitting allows for control testing, reducing the risk of deploying unstable or problematic changes to the entire user base. Data-driven decisions. It enables organizations to make decisions based on empirical data rather than assumptions, leading to more effective product improvements. User feedback. Can capture real user feedback on the new version, providing insights that might be missed in traditional testing. Gradual rollouts. For canary deployments, it offers a safe and gradual path to full deployment, minimizing potential harm to users. Azure DevOps release pipelines in conjunction with Azure services like Application Gateway and Azure Traffic Manager can facilitate traffic splitting for canary deployments and A/B testing, allowing organizations to iterate and improve their applications and services with confidence. What is rollback testing in Azure DevOps release pipelines, and how can it be implemented to validate the effectiveness of rollback procedures? Rollback testing in Azure DevOps release pipelines is a process of validating the effectiveness of the procedures and mechanisms in place to revert a deployment to a previous state in case of unexpected issues or failures. It ensures that the rollback process is well-defined, reliable, and can be executed with minimal disruption to the application or system. Here's how rollback testing can be implemented to validate the effectiveness of rollback procedures. Define rollback procedures. Before implementing rollback testing, it's essential to have well-defined rollback procedures in place. These procedures should outline the steps to revert the application to its previous state, including code, configuration, and data changes. Rollback procedures should be documented and accessible to the deployment team. Automate rollback steps. Whenever possible, automate the rollback steps to ensure consistency and reduce the possibility of human error. Automation scripts or templates can help revert the application to the last known good state efficiently. Rollback testing scenarios. Create a set of rollback testing scenarios that simulate common deployment issues or failures, such as application crashes, performance degradation, security vulnerabilities, or data corruption. These scenarios should trigger the need for a rollback. Integration with deployment pipeline. Integrate rollback testing into your deployment pipeline. It should be a part of the release process and run automatically after a deployment. If any of the rollback scenarios fail, the pipeline should trigger the rollback procedures. Monitoring and alerts. Implement monitoring and alerting mechanisms to detect issues that might require a rollback. For example, set up performance monitoring, log analysis, and error tracking to identify anomalies or critical errors. Pre-deployment backups. Ensure that you have reliable and up-to-date backups of critical components, including databases and configuration settings, before starting a deployment. These backups are essential for successful rollback. Dry run testing. Periodically perform dry run rollback testing in non-production environments to validate that the rollback procedures work as expected without causing further issues. This can help uncover any hidden challenges or dependencies. Testing in staging environments. Before applying rollback testing in production, test the rollback procedures in staging or pre-production environments to minimize risks and validate the process thoroughly. Documentation and training. Ensure that your team is well informed about rollback procedures and has access to the necessary documentation. Regular training and drills can help team members become proficient in executing rollbacks. Post-rollback validation. After a rollback is performed, conduct post-rollback validation to ensure that the application is functioning as expected and that no data or configurations were lost during the rollback process. Continuous improvement. Rollback testing is not a one-time activity. It should be an ongoing process. Periodically review and improve rollback procedures based on lessons learned from actual deployments and testing. How can you ensure immutable infrastructure in your Azure DevOps CI/CD pipeline, and what are the benefits of this approach? Answer: ensuring immutable infrastructure means that infrastructure components are never modified after creation. This can be achieved by recreating infrastructure from scratch during each deployment. The benefits include reliability, consistency, and improved disaster recovery since infrastructure changes are not cumulative, making it easier to pinpoint issues and roll back to a known good state. Explain the concept of continuous compliance in Azure DevOps and how it can be achieved. Answer: continuous compliance in Azure DevOps refers to continuously monitoring and enforcing compliance with organizational or regulatory standards. It can be achieved by integrating compliance and security scanning tools into your CI/CD pipeline. These tools automatically check your infrastructure and applications for compliance violations during deployments and provide alerts or block deployments when violations are detected. What is shift-left testing and how does Azure DevOps support this testing approach? Answer: shift-left testing is the practice of moving testing activities earlier in the development process, ideally starting at the coding stage. Azure DevOps supports shift-left testing by enabling the creation of automated tests that run during the build and release pipeline stages. This approach catches issues earlier in the development process, leading to faster feedback and higher quality code. How can you ensure zero downtime deployments for a mission-critical application using Azure DevOps release pipelines? Answer: ensuring zero downtime deployments with Azure DevOps release pipelines involves implementing database schema changes using techniques like rolling deployments or shadow databases, using traffic management and load balancing to gradually shift user traffic to the new version, implementing automated health checks and monitoring to detect issues quickly, having a rollback strategy ready to revert to the previous version in case of problems. Explain the role of post-deployment gates in Azure DevOps release pipelines and how they enhance deployment quality. Answer: post-deployment gates in Azure DevOps release pipelines are checks and validations that occur after the deployment to ensure that the release meets specific criteria. These criteria can include automated tests, performance monitoring, or other quality metrics. Post-deployment gates enhance deployment quality by adding an additional layer of verification, increasing confidence that the release is stable. What are load tests in Azure DevOps and how can they be incorporated into the CI/CD pipeline for performance testing? Answer: load tests in Azure DevOps are used to measure the performance and scalability of an application under various levels of load. They can be incorporated into the CI/CD pipeline as a task that runs during deployment to a performance testing environment. Load tests simulate user activity to assess how the application responds, helping identify performance bottlenecks. Explain how feature flags can be utilized in Azure DevOps to enable controlled feature rollouts and A/B testing. Answer: feature flags, also known as feature toggles, can be used in Azure DevOps to enable or disable specific features in your application. They are controlled through configuration settings, allowing controlled feature rollouts and A/B testing. By toggling features on or off in different deployment environments, you can gradually introduce new functionality and assess its impact on users. How does canary analysis enhance deployment reliability in Azure DevOps release pipelines, and what types of metrics can be analyzed? Answer: canary analysis involves comparing the performance and behavior of canary deployments with baseline deployments to detect discrepancies. In Azure DevOps, canary analysis can be achieved using tools like Azure Monitor or Application Insights. It allows you to analyze various metrics including response times, error rates, and resource utilization to ensure the reliability of deployments before fully rolling them out. What is shift-right testing and how does it differ from shift-left testing in the context of Azure DevOps? Answer: shift-right testing refers to the practice of moving testing activities into the production environment after deployment. This approach involves monitoring, real-world user testing, and collecting data in the production environment to identify and address issues. In contrast to shift-left testing, which occurs earlier in the development process, shift-right testing focuses on post-deployment testing and production feedback. Explain the use of release notes in Azure DevOps release pipelines and how can they benefit the development and operations teams. Answer: release notes in Azure DevOps release pipelines are documents or artifacts that provide detailed information about the changes included in a release. They benefit development and operations teams by offering transparency and communication regarding the contents of a release. These notes help teams understand what has changed, track issues, and ensure that all stakeholders are informed about the release's content and potential impacts. How can you automate rollback processes in Azure DevOps release pipelines, and what are the best practices for handling rollbacks effectively? Answer: to automate rollback processes in Azure DevOps release pipelines, set up a dedicated rollback pipeline that includes specific tasks to revert to a previous version. Use feature flags or configuration settings to easily switch between versions. Implement automated testing to validate the rollback. Ensure that the rollback pipeline is as reliable and efficient as the deployment pipeline. Best practices for handling rollbacks effectively include having a well-defined rollback plan, clear communication, and continuous monitoring. Explain the use of gated deployments in Azure DevOps release pipelines and their impact on release quality. Answer: gated deployments in Azure DevOps release pipelines refer to the practice of subjecting a release to various predefined gates and validations before proceeding to the next stage. These gates may include automated tests, manual approvals, and security scans. Gated deployments enhance release quality by ensuring that only releases meeting specific criteria and passing these gates proceed, reducing the risk of deploying faulty or insecure code. What is incremental deployment in Azure DevOps, and how can it be beneficial for large and complex applications? Answer: incremental deployment in Azure DevOps involves deploying only the changes or updates that have occurred since the last successful deployment, rather than deploying the entire application. This can be beneficial for large and complex applications by reducing deployment times, resource utilization, and the risk of introducing issues when deploying minor updates. It allows for more efficient and reliable deployments in such environments. Explain how runbooks and Azure DevOps release pipelines can automate post-deployment operations and management tasks. Answer: runbooks and Azure DevOps release pipelines are sets of automation scripts and tasks that can be executed after a deployment to manage and configure the application and its infrastructure. They can perform tasks like database updates, configuration changes, or scaling operations. Runbooks automate post-deployment operations, ensuring that the environment is correctly set up and configured after a release. How can you set up continuous delivery triggers in Azure DevOps, and what is their significance in CI/CD pipelines? Answer: continuous delivery triggers in Azure DevOps are used to automate the start of a new release when specific conditions are met. You can set up triggers to start a release automatically after a successful build, or based on specific branch policies or tags. Continuous delivery triggers ensure that new changes are continuously deployed to the target environment, improving efficiency and enabling rapid feedback. Explain the concept of pipeline artifacts in Azure DevOps and how they aid in sharing data between pipeline stages. Answer: pipeline artifacts in Azure DevOps are files or data generated during the build stage and made available for subsequent stages. They aid in sharing data between pipeline stages, ensuring that the outputs of one stage can be consumed by another. This is valuable when, for example, you need to pass build artifacts to a deployment stage or store test results for reporting. How can you ensure deployment parity in Azure DevOps when dealing with multiple environments, and what are the potential challenges to address? Answer: deployment parity refers to the consistency of deployment across multiple environments. To ensure it, use infrastructure as code IAC to define and provision environments consistently. Automate configuration and environment setup. Implement standardized deployment practices. Address challenges related to data consistency, environment-specific configurations, and third-party service integrations to achieve deployment parity. Explain how change approval policies in Azure DevOps release pipelines can enhance governance and control. Answer: Change approval policies in Azure DevOps release pipelines are used to require manual approvals or validation steps before a deployment proceeds to the next environment. They enhance governance and control by ensuring that designated stakeholders review and approve changes, helping to prevent unauthorized or problematic deployments. These policies help maintain compliance and minimize the risk of issues making their way to production. What are manual interventions in Azure DevOps release pipelines, and when might you use them during the deployment process? Answer: Manual interventions in Azure DevOps release pipelines are used to introduce human decision points during the deployment process. They allow stakeholders to review and decide whether to continue with the deployment or take a specific action. Manual interventions are useful when you need additional control, validation, or approvals before progressing with the release. Explain the concept of deployment rings in Azure DevOps release pipelines and how they can be used for controlled rollouts. Answer: Deployment rings involve progressively deploying a new release to a small subset of users or environments before rolling it out to broader audiences. In Azure DevOps, you can implement deployment rings by configuring your release pipeline to target specific environments, starting with a limited audience and gradually expanding to more users or environments. This approach helps identify issues early and ensures controlled rollouts. What are artifact filters in Azure DevOps release pipelines, and how can they be used to manage and filter release artifacts effectively? Answer: Artifact filters in Azure DevOps release pipelines are rules that allow you to control which specific versions of artifacts are eligible for deployment. You can use artifact filters to ensure that only approved or validated artifact versions are deployed to various environments. This helps manage and filter release artifacts effectively, promoting consistency and reducing the risk of deploying problematic versions. How does infrastructure drift occur, and what practices can help prevent or address it within the context of Azure DevOps? Answer: Infrastructure drift happens when the actual state of deployed infrastructure differs from the desired or documented state. To prevent or address infrastructure drift in Azure DevOps, use infrastructure as code (IAC) to define, provision, and configure infrastructure. Regularly audit and compare the actual infrastructure with the IAC templates. Automate infrastructure updates and corrections. Implement monitoring and alerting to detect and respond to drift in real time. Explain the concept of self-healing deployments in Azure DevOps release pipelines and how they can enhance reliability. Answer: Self-healing deployments in Azure DevOps release pipelines involve the use of automation and scripts to detect and automatically correct issues during the deployment process. For example, if a deployment encounters an error, a self-healing deployment may automatically roll back to a previous version or apply a corrective action without manual intervention. This enhances deployment reliability and minimizes downtime. What are environment conditions in Azure DevOps release pipelines, and how can they be used to control the flow of releases? Answer: Environment conditions in Azure DevOps release pipelines are rules or criteria that determine when a release can proceed to a specific environment. They can be used to control the flow of releases by specifying conditions like time-based triggers, branch filters, or custom variables. Environment conditions provide fine-grained control over release progression, ensuring that releases are deployed according to defined criteria. Explain how tagging of resources in Azure DevOps release pipelines can aid in resource management and cost control. Answer: Tagging resources in Azure DevOps release pipelines involves adding labels or metadata to resources, such as virtual machines or databases. This aids in resource management and cost control by providing a way to categorize and track resources. You can use tags to identify the purpose, owner, environment, or cost center of each resource, making it easier to manage and allocate costs effectively. How can you implement cross-environment configuration consistency in Azure DevOps release pipelines, especially when dealing with environments that have different requirements or configurations? Answer: implementing cross-environment configuration consistency in Azure DevOps release pipelines involves using environment-specific configurations that are maintained separately from the application code. You can create environment-specific configuration files, use environment variables, or integrate with configuration management tools. This ensures that each environment has the correct settings while maintaining configuration consistency across all environments. Explain the concept of secret rotation in the context of Azure DevOps and why it is important for security. Answer: secret rotation is the practice of regularly changing and updating sensitive credentials and keys, such as API tokens and passwords, to enhance security. In Azure DevOps, secret rotation is important for mitigating the risk of unauthorized access to sensitive information. It ensures that even if a secret is compromised, it becomes obsolete after a rotation, reducing the window of vulnerability. What is the role of canary releases in Azure DevOps release pipelines, and what strategies can be used for gradual rollouts? Answer: canary releases in Azure DevOps release pipelines involve deploying a new version of an application to a small, controlled subset of users or environments. Strategies for gradual rollouts can include techniques like percentage-based deployments, geo-distributed rollouts, or A/B testing. Canary releases allow for early detection of issues, ensuring a safer rollout to a broader audience. What is blue-green database deployment, and how can it be achieved in Azure DevOps release pipelines while minimizing data migration challenges? Answer: blue-green database deployment involves transitioning an application to a new version with a separate database while minimizing data migration challenges. In Azure DevOps release pipelines, you can achieve this by using techniques such as database snapshots, replication, or redirecting application connections to the new database. These methods help ensure minimal data migration complexities during the transition. Explain the concept of continuous experimentation in Azure DevOps release pipelines and how it can contribute to product improvement. Answer: continuous experimentation, often associated with A/B testing, involves continually testing variations of a product or feature to gather data and insights for improvement. In Azure DevOps release pipelines, you can incorporate A/B testing as part of the release process to experiment with different versions of features, gather user feedback, and make data-driven decisions for product enhancement. How can you implement feature toggles in Azure DevOps release pipelines to enable or disable specific features during runtime? Implementing feature toggles in Azure DevOps release pipelines involves integrating feature flagging libraries or configurations into your application code. These feature toggles allow you to enable or disable specific features or changes during runtime without redeploying the application. This flexibility aids in controlled feature rollouts and risk mitigation. What is dark deployment, and how can it be executed in Azure DevOps release pipelines for safe, unobtrusive updates to a production environment? Dark deployment, also known as shadow deployment, involves deploying a new version of an application in parallel to the existing production version without affecting live users. In Azure DevOps release pipelines, you can execute a dark deployment by setting up a separate environment or isolated testing environment for the new version. This approach allows you to test the new version without impacting production users, ensuring safe updates. Explain the concept of blue-green infrastructure and how it aligns with blue-green deployments in Azure DevOps release pipelines. Answer: blue-green infrastructure refers to having two identical environments, blue and green, where one is active, live, while the other is inactive. Blue-green deployments in Azure DevOps release pipelines involve transitioning between these environments. When the green environment is ready and validated, it becomes the active environment, and the blue environment becomes the inactive one. This approach ensures quick and safe rollbacks if issues arise. How can chaos engineering be incorporated into Azure DevOps release pipelines, and what benefits does it bring to application reliability and resilience? Answer: chaos engineering involves introducing controlled disruptions or faults into a system to test its reliability and resilience. In Azure DevOps release pipelines, you can incorporate chaos engineering by using tools like Chaos Monkey to simulate failures. This approach helps identify weaknesses in your application's fault tolerance and recovery mechanisms, leading to improvements in reliability and resilience. Explain the concept of compliance as code in Azure DevOps and how it can help ensure regulatory compliance in the CI/CD process. Answer: compliance as code involves defining and enforcing compliance rules and policies as code within the CI/CD pipeline. In Azure DevOps, this could be achieved through automated compliance checks, security scanning, and audit logs. Compliance as code ensures that regulatory requirements are consistently validated during deployments, reducing the risk of non-compliance. How can custom deployment gates be implemented in Azure DevOps release pipelines, and what scenarios might require custom gate logic? Answer: custom deployment gates in Azure DevOps release pipelines can be implemented by creating custom scripts or extensions that define specific validation or approval criteria for releases. Scenarios that may require custom gate logic include complex validation checks, external system integration, or unique business process requirements that cannot be addressed with built-in gate types. What is the role of canary analysis in Azure DevOps release pipelines, and how can it be used to validate deployments and identify issues early? Answer: canary analysis in Azure DevOps release pipelines involves comparing the behavior and performance of canary deployments with baseline deployments to detect discrepancies. It can be used to validate deployments by analyzing various metrics, such as response times, error rates, and resource utilization, helping identify issues early in the deployment process. Explain the use of safety checks in Azure DevOps release pipelines and how they contribute to risk management in the deployment process. Answer: safety checks in Azure DevOps release pipelines are predefined checks and validations that assess the readiness and safety of a release. They include predefined conditions like tests, health checks, and configuration validation. Safety checks contribute to risk management by ensuring that a release meets specific criteria and is safe to proceed, reducing the likelihood of deployment issues. What is hotfix deployment, and how can it be executed in Azure DevOps release pipelines to address critical issues without affecting the entire application? Hotfix deployment involves quickly addressing critical issues in a production environment without making extensive changes to the entire application. In Azure DevOps release pipelines, this can be executed by creating a separate release pipeline or configuration for hotfixes, which allows for the rapid deployment of specific fixes or patches while minimizing disruption to other parts of the application. Explain how environment seeding can be employed in Azure DevOps release pipelines to automate environment provisioning and configuration for various stages of the deployment process. Environment seeding in Azure DevOps release pipelines involves automating the provisioning and configuration of environments required for different stages of the deployment process. This can be achieved by using infrastructure as code, IAC, templates, and automation scripts to create and configure environments dynamically. Environment seeding streamlines the deployment process and ensures consistency across environments. What is the role of manual post-deployment validation in Azure DevOps release pipelines, and when might it be necessary for ensuring deployment quality? Manual post-deployment validation in Azure DevOps release pipelines refers to the practice of conducting manual tests or validations after a deployment has completed. It might be necessary for ensuring deployment quality in cases where certain tests or validations cannot be automated, or when additional human insight is required to assess the application's behavior or usability in a specific environment. Here's an extended explanation and some common scenarios when manual post-deployment validation is necessary. Quality assurance. Manual validation is often used to ensure the quality of the deployment. Even with extensive automated testing, there can be certain aspects that are best evaluated by a human, such as the overall user experience, visual design, and adherence to business requirements. Compliance and security checks. In regulated industries or organizations with strict compliance requirements, manual validation allows for checks to ensure that the deployment complies with all necessary regulations and security standards. User acceptance testing (UT). Before making a deployment available to end users, it's common to perform UT. Stakeholders or a designated group of users may need to validate that the changes meet their expectations and don't introduce unexpected issues. Feature flag activation. Sometimes a new feature may be deployed but not enabled for all users immediately. Manual validation can help ensure that feature flags are activated correctly for the right set of users. Data verification. In cases where data migration or data transformation is part of the deployment, manual validation may be necessary to verify that the data is accurately migrated and transformed. Rollback planning. Manual validation is crucial for determining whether a deployment is successful and stable. If issues are identified during the manual validation process, it can trigger a rollback plan to revert to the previous version, preventing negative impacts on users. Exception handling. In scenarios where automated testing encounters issues, manual validation can provide a fallback mechanism for handling exceptional cases, ensuring that issues are addressed appropriately. Performance testing. Performance and load testing might require manual validation to assess whether the application meets the expected performance criteria under real-world conditions. What is the purpose of variable groups in Azure DevOps, and how can they simplify pipeline configuration? Variable groups in Azure DevOps are sets of variables that can be used across multiple pipelines. They help simplify pipeline configuration by allowing you to define variables like connection strings, API keys, or environment-specific settings in a central location. Changes made to variable groups are automatically reflected in all pipelines that use them, reducing redundancy and enhancing maintainability. Explain the concept of environment templates in Azure DevOps release pipelines and their advantages in maintaining consistent deployment practices. Environment templates in Azure DevOps release pipelines allow you to define standardized configurations for deployment environments. They ensure consistent deployment practices by encapsulating deployment steps, approvals, and security settings. Environment templates simplify the creation of new environments, helping maintain uniform deployment practices across different stages and projects. Explain the YAML-based approach in Azure DevOps pipelines. The YAML-based approach in Azure DevOps pipelines is a method for defining and configuring your CI/CD, continuous integration/continuous delivery, pipelines using YAML 8 markup language files. Instead of using the Visual Designer in the Azure DevOps portal, you write pipeline configuration as code in YAML format. This approach offers several benefits, including version control, code reuse, and better visibility into your pipeline's configuration. Here's an explanation of the key aspects of YAML-based pipelines in Azure DevOps. Infrastructure as code. IAC using YAML to define your pipelines treats your pipeline configuration as code, which can be versioned, reviewed, and stored in source control repositories. This aligns with the principles of infrastructure as code and enables collaboration among team members. Readable and maintainable, YAML is human-readable and easy to understand, making it accessible to a wide range of team members, from developers to operations. This transparency can improve the maintainability of your pipelines. Configuration flexibility. YAML-based pipelines offer flexibility in defining your build and release workflows. You can specify build tasks, deployment strategies, triggers, and other pipeline settings in a structured YAML file. Version control. YAML pipeline files can be versioned alongside your application code, allowing you to track changes and roll back to previous pipeline configurations if needed. This versioning is vital for auditing and maintaining historical pipeline configurations. Continuous integration and continuous delivery. YAML-based pipelines can be used for both continuous integration, CI, and continuous delivery, CD scenarios. You can define the entire pipeline from code compilation and testing to deployment and release. Easy branching and environment support. You can define different YAML files for different branches or environments, tailoring your pipeline configurations to specific requirements, such as deploying to development, staging, or production environments. Pipeline as code. YAML-based pipelines are part of the pipeline as code approach, which treats the CI/CD pipeline itself as a piece of code. This aligns with modern DevOps practices, enabling automated testing and validation of the pipeline configuration. Don't miss out on part 3 of our video series. It's packed with even more valuable insights and answers to Azure DevOps interview questions. If you found part 1 and 2 helpful, part 3 is a must-watch to complete your preparation.
Hey, if you like the content, please subscribe to my channel. Don't forget to ring the notification bell so you never miss a bite of Azure brilliance.